All right, if you're building anything with AI, you've definitely run into this problem. How do you get your awesome model connected to real-world live data? Well, that's what we're tackling today. We're going to demystify a new open-source standard that's designed to solve exactly that. It's called the Model Context Protocol, or MCP for short.
I mean, this is the big one, right? You can have the smartest large language model on the planet, but it's not really magical until it can actually talk to the world outside of its training data. So how do we plug it into live databases, APIs, and all that good stuff that makes an app genuinely useful and, alive? Yeah, this whole thing, this problem, it has a name, the Agent Data Challenge. It's all about building that bridge, that connection between an agent's brain and the real-world data it needs to do its job. And up until now, building that bridge has been this painful, custom job. You have to do it from scratch for every single project. It's just a ton of repetitive work. And that is exactly where MCP comes in. To put it simply, the Model Context Protocol is this new open-source standard built to fix this mess. It gives you a standard, repeatable way to connect your AI agents to pretty much any data source you can think of, databases, APIs, you name it. Yeah, think of it like the universal power adapter for your AI. One plug to rule them all.
Okay, so how does this actually work? To really get it, we need to pop the hood and look at the main parts. So let's meet the key players in this whole setup.
First up, you've got the MCP host. Now, this is basically your main application. It's the thing your user's actually clicking on and typing into. So it could be a chat app, or maybe a code assistant right inside your editor. Really, any app that has an AI agent inside. This is the agent's home base. All right, next we have the MCP server, and this piece is super important. It's like the data gatekeeper. The server is a component that actually does the dirty work of connecting to all your data, your databases, your APIs, and then it presents them as a nice, clean set of tools that the host can ask for. So, how do the host and the server actually talk to each other? Well, that's where the MCP protocol comes in. The protocol is the rulebook. It's the shared language that lets them communicate without any confusion. It's kind of like HTTP for the web, but this is the transport layer for agent tools. It's that common ground that makes it all work together, no matter what agent or data source you're using. So what you end up with is this really simple but powerful relationship. You've got the host on one side, basically asking for stuff. Hey, what tools you got? Or can you go run this for me and get some data? And on the other side, you have the server whose whole job is to say, yep, here are the tools and here's the data you asked for. It's a really clean separation of duties. And the cool thing is just how flexible the MCP server is. I mean, it is not picky about where the data lives. It can connect to your standard relational databases, NoSQL databases, pretty much any API you can throw at it, even local files on your machine. And get this, it can connect to source code repositories, which is just awesome if you're building, say, a coding assistant. Okay, so we have the host, the server, and the protocol. We have all the pieces, but how do they actually play together? Theory is one thing, but seeing it in action is what makes it all click. So let's walk through a step-by-step example. We'll use a simple chat app. Check out this flow. It's like a really elegant little dance between all the parts. So it all kicks off when a user asks a question. Now here's the key part. The host app doesn't just guess what to do. First, it asks the server, hey, what tools are available? Then it takes the user's question and that list of tools and sends them both to the large language model. The LLM acts like the brain here, figuring out, this is the right tool for that question. The host then tells the server to execute that specific tool. The server gets the data, sends it back, and then the LLM can put together the final perfect answer. It's this super smart and efficient loop that keeps the app logic totally separate from the data fetching stuff. So, okay, why does any of this matter to you, the developer? The thing is, this is way more than just another protocol. MCP is really shaping up to be a new standard for AI agents, and that has some pretty big implications for anyone building in this space.
Yeah, the whole mission, the big idea behind MCP is to let you connect any data source to any agent. Just think about that. You could build a connection to your data using an MCP server one time, and then any agent you build from now on, or even one you grab off the shelf, can plug right into it. That's the real power of a standard. Your work becomes portable, reusable, and way more scalable.
And this right here, this is the real payoff. As a developer, think about where your time goes. So much of it is spent just building custom connectors, all that boring, repetitive plumbing. With a standard like MCP, you let it handle all that heavy lifting. And that frees you up to spend your time and your brain power on what really matters, the cool, unique, intelligent logic of your agent.
And really, that's the whole story. MCP is here to standardize the connections, to tear down one of the biggest roadblocks we've had in building truly powerful data-aware AI. It just opens up a whole new world of things we can create. So I'll leave you with this one question. Now that your agents can connect to pretty much anything, what are you going to build?